Okay, so today we are going to talk about graphing log problems, and this is very conceptual. This is not a whole lot of calculating. Most of what you will be doing is interpreting. As far as graphing logs themselves, I expect you to do most of them on your graphing calculator. Sometimes you'll have to manipulate the problem to get there. So let's just talk through this really quick about what kind of graphing logs and their asymptotes and those kind of things. So first of all, realize that if you look here, right here, the idea that the log is an inverse of y equals a to the x, and a can be any number that is over 0. It cannot be less than 0. So just a couple of notes here. This is something you can write down. You can refer back to the video. This is also in your book. So first of all, if a is always greater than 0, okay, the range is going to be greater than 0, then the domain of the inverse, right here, is going to be the same as the range. Realize that when we do inverses, their ranges and domains flip. So, so the domain of the inverse, so if the range of the original function is y is greater than 0, and then the domain of the new function will be x is greater than 0. Okay, the range will be that y is all real numbers. So, and again, it just notes it again that if the domain and range are the opposite, so the domain of f to the inverse is the same thing as the range of f. The range of f to the inverse is the domain of f. So, and again, these are very conceptual ideas. The idea that you can swap those around. So let's look at graphs. Now you'll notice we have two different graphs here. One is saying that so we have the graph of y equals a, y equals log a x, okay, right here. Okay, it's saying if this a value right here is less than 1 but greater than 0. So we're talking about fractions, decimals, those kinds of things that are less than 1. Okay, the y equals log ax is going to look like this. Okay, if a is greater than 1, so anything bigger than 1, no decimal. Well, you could have decimals and fractions, but they would be bigger than 1. The graph is going to look like this. These are just pictures. Just get used to them so that you're comfortable with them. So that if I were to give you a graph, you could tell me whether it was less than 1 or greater than 1. So again, these are just pictures. This is conceptual. There's no calculating here. There's a lot of information that are on these graphs you don't necessarily need to know at all. Okay. Moving on. So this is the same graph we just looked at, but I wanted to cover a couple of different things, just notes here. Okay. Basically, you notice again the idea of the reflection. So the graph y equals a to the x right here is the inverse. It's reflected over the y equals x line, so that is why the log is that. Same thing here, they're inverses, they're reflected over the y equals x line. Okay, functions have domain of x equals 0. You know we can only find logs of positive numbers. Okay, that's just a note that we already know. So again, conceptual stuff. You can look through these, read through these. I'm not going to go over them all because it's easier once we start interpreting some examples. All right, so first of all, here we have this function. Consider the function f of x equals log 2 of x minus 1 plus 1. And it says find the domain and range of f. Now something I'm going to do is I put these examples on here because they're very close to your homework problems. But what I would like you to do before you do anything is to graph this in a graphing calculator. Now this is a little bit harder than it looks because what you have to do, if you'll notice here, it's not log base 10. You don't have log base 10 in your calculator, so you have to change. The base. Okay. So what we can rewrite this as f of x equals log x minus 1 over log 2 plus 1. And this will be the whole thing that you will put in your graphing calculator. Okay, make sure you use parentheses. Okay, parentheses here, all right? Maybe parentheses around the whole thing so you don't actually divide by the plus 1. right? And when you put that in your graphing calculator, this right here is the graph that you will get. Now when I ask for things like domain and range, asymptotes and those kind of things, I want you to interpret from a graph. That's going to be the easiest way to do this. So when you find the domain and range of x, first of all, we can look at the idea of the domain is all the x values. So if we look on the x axis here, okay, our graph is never going to go below 1. Now if you notice, it gets right at 2 and then it goes right here. So the domain is x is greater than 1. It's not including 1 because guess what? There's an asymptote there. It's never going to cross that line. And then the range, you notice the range is going to go down all the way and it's going to keep climbing that direction. Okay, so the range is y is all real numbers, right? There is a vertical asymptote at x equals 1. So we'll need that. So let's look at what it asks us for. The domain and range, find any asymptotes, okay? Axes, intercepts. So you'll notice it intercepts right here, which is, I'm off just a little bit on my smartboard. So you'll notice here it crosses just under 2. So again, I'm not going to ask you to be exact here. So you could say that x is approximately 2. It's not quite, all right? Sketch the graphs, okay, and find the inverse. Now, this is the hardest part. You notice it does not ask you to find the inverse graph, it just wants you to find the inverse. So if you remember finding inverse, okay, f to the negative 1 of x, all right, what we have to do is we actually have to swap the values. So this would be considered y equals log, and I'm going to start over here. Say this is y equals log 2 x minus 1 plus 1. And we're going to swap the x's and y's. X equals log 2 y minus 1 plus 1. And I am going to solve for y. All right? This is probably one of the hardest things I've asked you to do all year. So what we're going to do first is we're going to and I gotta look at how I want to approach this. I apologize. This is a very hard concept. So we want to solve for y. So we want to get that y out of the log itself. Well, let me get rid of this one. Let's back one on both sides. X minus 1 equals log 2 y minus 1. Okay. I can't do. Yes, I can. Okay, now I'm going to use the rule of y. A to the x equals b, that rule right there. So I'm going to go this 2 here. Okay, so 2 to the x minus 1 equals y minus 1. Then I will subtract 1 from both sides. And I get 2 to the power x minus 1 minus 1 equals y. So we'll do another example. I know that was tough. So these are the kind of things that your homework's going to be asking. And any of the graphing things, I would like you to graph them on a graphing calculator and pull all of your information from there. I'm not going to expect you to graph these on your own. So, all right, here's another one. It says consider the function f of x equals x e to the x minus 3. So it says find the defining equation of f to the negative 1. Okay, that's basically saying find the inverse. Again, vocabulary in these books is kind of odd. That's why I pulled these examples specifically from there. So we're going to find the inverse first. So we're going to go, that's not a good color, sorry. We'll go y equals e to the x minus 3. We're going to swap them. X equals e to the x minus 3, or the y minus 3. Again, I want to get that y out of the exponent, so we're going to take the natural log of both sides. And these are all those solving techniques we worked on in class yesterday, or today. So I have ln of x equals y minus 3. So it's ln x plus 3 equals y. So this is my function, this is my inverse. So we sketch the graph on the same axes. Okay, again, you can do this in a graphing calculator. Okay, graph them both. State the domain and range. Okay, so if you'll notice here, okay, which one's which? Okay, I'm pretty sure this is this one, and that one is that one. Okay, so the domain for the, hang on, I have that wrong. That goes with that one. This goes with that one. Okay, so the domain for my original function is from, basically from negative infinity to infinity. It looks like there might be an asymptote. I don't think so. I think it keeps, maybe. There might be an asymptote, but it's very difficult to see what it is. So we'll just call the domain for this one all real numbers. And this one, you'll notice approaches, it looks like it's touching 0, but I'm pretty sure there's an asymptote there. I think this graph is off just a little bit. So the asymptote is x, y equals 0. So my domain is, or my range is sorry, I have this myself. I apologize for this. I would start this video over, but then I have a lot of work that I have to fix. So ignore what I just said. Okay, domain and range. Domain is my x values. You'll notice my x values go from 0 to infinity. I didn't have that right. Okay, domain is all real numbers. Range, okay, we cannot go below 0, so it is y is greater than 0. All right, moving on. Let's do a couple more examples. I told you this would be long. I'm sorry. All right, so this is a problem directly from your homework. Your homework directions will be just like this. So it says, for the following functions that find the domain and range, find any asymptotes and x-intercepts, sketch the graph of y equals f of x showing all important features. Now, I'm not going to do this part of the example with you, okay? This is graphing calculator stuff. So do it in your graphing calculator. If your answers are close, even if they're not exact, I'm okay with that, okay? I'm looking for approximations, get comfortable with what they look like. What I want to do is I want to do the inverse, and also this solve f of x for -1. So this is asking you to do a couple of different things. Again, this is all solving and manipulating log problems. So what I want to do here is this first one says if f of x equals -1, all right, we're going to go -1 equals log 3 of x plus 1. All right, I'm going to use this rule, a to the x equals b. All right, so 3 to the -1 equals x plus 1. Right. So this is 1/3 equals x plus 1 minus 1 from both sides, and I have x equals -2/3. Okay. I wanted to do this with you because I think this is an interesting skill to have. If it tells you that f of x equals -1, can you solve the equation? You plug it in for f of x and solve the equation from there. So now it also asks us to find the inverse. So if I have f of x equals, well, let's change that to make it y equals log 3 of x plus 1. Okay, and I want to do the inverse. I'm going to go x equals log 3 of y plus 1. Okay, I'm going to use my rule again. Be a to the x equals b. So it's 3 to the x equals y plus 1. Subtract 1 from both sides, and I have 3 to the x minus 1 equals y. There's my inverse. Okay. So these are the questions that your homework will ask. Again, the first 3 questions on here, those are graphing calculator. I don't think I need to go over those again. This video is running very long. So on to the next one. Okay, so again, this is a second part of your homework tonight. It says find the defining equation of f equals -1. And it asks you to sketch both graphs on the same axis. I do want you to show those pictures, do them on the graphing calculators, but then write them on your homework. And then state the domain and range. You can find those from the graphs. and then find any asymptotes. So 2, 3, and 4 I'm not going to do with you, but I will find the inverse. So this is y equals e to the x plus 5. Okay, the inverse, I swap them. X equals e to the y plus 5. Now what I'm going to do is I'm going to subtract 5 from both sides. And then x minus 5 equals e to the y. Now I'm going to find the natural log of both. So that's the natural log of that, natural log of that. And I end up with the natural log of x minus 5 equals y. Alright, I'm going to end the video here. Okay, I hope I didn't overwhelm you too bad. The graphing and the conceptual stuff is kind of tough. I hope that you have a good enough understanding of it that you can do those on the graphing calculators. Likewise, the inverses, I hope I did enough examples to help you find those. So good luck on your homework.